We're all used to the idea of a number line, and it all depends on its use, you know, what we consider to be a good idea for the numbers. Now, in this one, I've chosen the gap to be 5, so that then it's another 5, 10, another 5, 15. You know, it's all down to the scale that's appropriate to what we're using. What we're going to be taking a look at number lines, but in a particular way of applying them. Right, here is a number line, and there we go. Actually, I made that a bit longer than I intended. Let's lift it up a bit. Go on, up you come. I'm going to start counting at 0. You don't have to. It all depends on your use. Now, these are estimated lengths, visually estimated, so they may be a bit wrong. I'm going to give that a value of 1, that one there a value of 2, that one there a value of 3, and that one there a value of 4. Now imagine all those gaps being the same. I'm going to draw another number line up here, and it's meant to be parallel to this one, and 0 will match to 0. 1 I'm going to match to 4. 2 I'm going to match to 8. So we got lines there like that. That one I'm going to match to 12, and this one I'm going to match to 16. Now this, for example, this line here, let's shorten that, shall we? This line here is going to represent a count of bags, and this one's going to represent a count of apples that are in a bag. So one bag has 4 apples. 2 bags, you have 8 apples. 3 bags, you have 12. There's a direct link here. It's a bit like we have now. If you cast your mind back to the early years, you have a number machine, you put a value in 2 and you get a number out, for example 16. You do something to this number here and you get the output there. So the input is 2, the output is 16. In a way, there's a number machine between each of these values. We just don't know what it is yet. Let's get rid of that. What we are showing is that there is a link between the number on this line here and the number on that line there. If you want to go beyond functional skills level, you could say it maps to. So 1 maps to 4. A bit like the path on a map, you know, it takes you to somewhere. So this one here maps to 8, and this one here maps to 12, and this one here maps to 16. Do not use equals. You know, 1 does not equal 2. I've seen people do that. That is wrong. That is so wrong. Don't put an equals. It maps to. 1 maps to 4. You know, they do that in sequences. You see, I see it often. You have the count number 1, 2, 3, 4, and they say equals, I don't know, 16, then a whole pile of other numbers with equals, and they represent a sequence of numbers that way, and that is wrong. Do not use the equal sign. Okay, notice that, well, it's slightly out. The angle there is meant to be 90 degrees, 90 degrees, 90, 90, 90, 90, 90 and 90. That idea is important. Keep that in mind. It doesn't have to start at 0. It could start at some other number. This is just where we're starting to count from. I'll show you what I mean a bit later. Right, now just think of that there. We have, if you like, the output, input. I want to move this number line such that this one here is like that, and this one here is like that. They're still number lines, alright? Okay, we have our number line here, which was the bags. And we have a number line up here, which was the apples. Here we had no bags. 1 bag, 2, 3, 4. That goes that way. Now I've chosen this number line to also start at 0, and we had, what was it, 4 per bag, wasn't it? So it's 4, 8. Well, I'm not sure it was 4, but it is now. 12, 16. 1 bag, draw a line up at the 90 degrees, draw a line across at the 90 degrees. That is the point we're interested in. That point represents the mapping from here to there. It's sort of saying there's a roundabout, you need to go round the roundabout and come off here. A bit like a roundabout on a road. No bags, no apples, so we have a point there as well. 2 bags, meant to be 90 degrees. 2 bags, roundabout, 8 apples. Come up there. Not very well drawn. You know, these are meant to be 90 degrees. 3 bags, 12 apples. There's, if you like, your roundabout. 4 bags, 4 bags, turning point, 16 apples. Now we should get a straight line graph. Depends how well I've drawn it. That's not too bad. So if we have half a bag, come up here, go across there, we have 2 apples. 1.5 bags, come up there, go across. We have 6 apples. Yes. See the way it works? This line represents where you turn when you're coming up to get to the other axes. It's a line because you can have any value in between. Any value between here can come up and go across any value there. That is how a straight line graph works. Now the thing is, that is 0, that is 0. That's fine. Sometimes you don't have them line up 0 to 0. Suppose we have here instead degrees centigrade, degrees Fahrenheit. 0 centigrade is in fact 32 degrees Fahrenheit. So the turning point there is different the value at the end after you turn is different. See, they don't have to be 0, but this is not normally done that way. This is not normally done that way. Let me get rid of this. As before, we have our horizontal axis and we have a vertical axis. Here is the 0, 4 degrees centigrade. This is Fahrenheit. When centigrade is 0, if that is 0 there, the 32 Fahrenheit could be up there somewhere. So in fact, if you come up 90 degrees from this line, from the 0, and it happens to coincide with that there, that is your point where it crosses the axes. 0 degrees represents 32 degrees. 0 degrees centigrade represents 32 Fahrenheit. Okay, let's actually roughly plot some numbers, shall we? Looking at my list, I've gone from... Now on the centigrade axis this time I'm going to jump 10 spaces for each division. So 0 to 10, 10 to 20, 20 to 30. I'm not going to go higher than that. Now 10 degrees centigrade is that's 30, 40, 50, somewhere around about there, is 50 degrees. So a 10 would come up here like this. At 90 degrees, come out there, at 90 degrees. That's your turning point, so you come up, go across. So 10 degrees centigrade maps to 50 degrees Fahrenheit. (20 degrees centigrade maps to 68, 30, 50, 60, somewhere around about here. I'm guessing my scales are bound to be slightly off. That's your turning point. So your line comes up here, 90 degrees from the horizontal, turns around a bit and goes along to this axis here. That is 90 degrees. That is 90 degrees. If you like, it's a straight road roundabout, come off here to the left. And that is how it works. Now you've got 30. 30 comes up here. And 30 converts to 86, 60, 70. I'm guessing, wait a minute, let me do there. Comes along. Say there. And it converts to 86. So 30 degrees centigrade comes along here, turns around and goes there. And that is how the graphs work. Let's see. It's not too bad. Not a bad guess. Now the thing about this is it can also go that way. Try and get it to look right. So we're getting into negative degrees. If I draw a line here, that's your axes. Come below this line here and the Fahrenheit is negative. Go beyond this point here, the centigrade is negative. And this is how a straight line graph works. You plot from one value to another. It's like a graph, a pictorial representation of a number machine. That's all it is. We're going to be looking in the next video at the equation of a straight line graph.